Force on a moving charge in a magnetic field and forces between two parallel current-carrying wires. In this module you learn that a moving charge in a magnetic field and two parallel current-carrying wires experience a force. You may know that a current-carrying wire experiences a force when it is placed in a magnetic field. You may also know that the current is the flow of electric charges, that is, free electrons in a wire. Here you'll examine the effect of a moving electric charge in a magnetic field. Take a look at this figure. The crosses represent a part of the magnetic field. The direction of the magnetic field is into the plane of the paper, away from you. When a beam of positive charge, for example protons, enter the magnetic field region, the beam is deflected upwards in a circular path. This deflection of the beam of positive charges is because the moving charges experience a force perpendicular to their direction of motion. The direction of this force can also be predicted by Fleming's left-hand rule. You can assume current to be in the direction of the beam of positive charges. However, if you have a beam of electrons or negative charges, you follow the conventional current direction, which is opposite to that of electron flow. This figure shows that a negatively charged particle is deflected downwards in the same magnetic field. This figure here shows that the beam of positive charges or protons enters a region of a magnetic field which is directed out of the plane of the paper towards you. The beam is now deflected downwards. You will next learn about the forces between two parallel current-carrying wires. When two current-carrying wires are placed parallel to each other, you would expect a force to act in each wire. This figure demonstrates the forces that exist between two parallel current-carrying strips of aluminium. When the current in each of the conductor flows in the opposite direction, the strips repel. However, when both currents are in the same direction, they attract each other. So you can summarize the forces between two parallel current carrying in opposite directions and similar directions respectively. This magnetic field pattern of a current carrying wire can be found by applying the right-hand grip rule. In this module you've learned the following. When a moving charge enters a magnetic field, the beam experiences an upward or downward deflection of force depending on whether the charge is positive or negative. When two current-carrying wires are placed parallel to each other, each of the wires experiences a force. When current flows in the opposite direction in the two wires, repulsion occurs. When current flows in the same direction in the two wires, attraction occurs.